Urination is an essential process in our daily life. But have you ever wondered what is actually inside our urine? Urine may be seen as a simple liquid that we excrete every day, but it actually contains many tiny particles, such as 95% of water, 5% of waste product, which include urea, creatinine, ammonia, and also uric acid that cannot be seen with naked eye.
To study this particle, scientists use a technique called centrifugation, where a sample is spun at high speed in a machine called a centrifuge. Although centrifugation is widely used in biology and medical laboratories, the process itself mainly explained using physics principles, especially circular motion and centrifugal forces. In this video, I will explain how urine centrifugation works and how physics plays an important role in separating the component inside the sample. Behind the process of centrifugation, there is a physics concept used known as centrifugal force. In this environment, the red sphere is 100 times denser than the white sphere. Under normal pull of gravity, it quickly sinks to the bottom. But if we are in a zero gravity environment and still need to separate these particles, we need another way to create the downward pressure. That's where the centrifuge comes in. As the device rotates, it generates centrifugal force. This outward force acts on every sphere in the chamber. The faster the rotation, the stronger this force becomes, rapidly pushing the spheres toward the outside walls. Even if there is only a very slight difference in the densities of these particles, the centrifugal force is powerful enough to drive a separation. The red spheres seem to move almost magically toward the outer boundary, fueled by the intensity of the spin. Within this rotating frame, centrifugal force acts as a simulated gravity. It pulls the denser red sphere outward with more intensity than the lighter white spheres. This creates a high pressure environment where the spheres are forced to rearrange based on their mass. Because of this continuous outward centrifugal force, the denser red sphere pushes the less dense white spheres out of the way. The red sphere concentrates against the furthest wall, effectively sinking to the bottom of the rotation. It works exactly like the high-speed version of objects sinking in water, but driven by rotation instead of Earth gravity. First, we have the centrifuge machine, which is the main instrument that spins the sample at high speed. Next are the centrifuge tubes, which hold the urine samples during the spinning process. Another important component is the rotor, which is the part inside the centrifuge that holds the tubes and rotate them around the center. Last but not least, we also need a pipette and also a microscope if the sediment is going to be examined after the centrifugation process. First of all, we need to prepare all the equipment required for this experiment. As shown, the procedure begins with collecting a urine sample and transferring it into a centrifugal tube. To ensure balance, the other tube must be filled with another liquid with the same volume as the first tube. Before inserting the tube, we need to ensure that we record the position number of each sample for sample identification, and also always keep the load balanced so that we can get accurate result at the end of the experiment. The centrifuge is then set to rotate at a specific speed for 5 minutes. After centrifugation, firstly we need to wait for the centrifuge to completely stop before remove it carefully from the centrifuge machine and place it at the test tube rack. After the centrifugation process, two distinct layers can be observed in the tube, which is the upper layer known as supernatant and lower layer known as pellet. Supernatant contain lighter components and dissolved substances such as water, urea and creatinine, dissolved salts and ions, and also small molecules that do not settle. These remain in the liquid because they are too small or too light to be pushed down by a centrifugal force. Move on to the pellet, which contain heavier and denser particles, such as red blood cells, white blood cells, epithelial cells, bacteria or microorganisms, crystals, and also cars. These particles settle because they experience greater centrifugal force due to higher mass and density. Centrifugal force can be expressed as F equal to m omega r squared, which is F is the centrifugal force, m mass of particles, omega is the angular velocity, and r, which is the radius from the center of rotation. This shows that the force increases with mass. Therefore, particles with higher mass and density experience a greater upward force. As the result, they move faster to the bottom and form the pellet, while lighter particles remain in the supernatant. In conclusion, urine centrifugation is an important application of physics in real-life situations. It plays a vital role in the medical field by allowing efficient separation of urine components for analysis. This technique helps healthcare professionals obtain accurate results and supports the diagnosis of various conditions. And that's how physics makes a real difference in our life.